Hey everyone, this is Jyotheeswara Reddy Gottam. I have been in software development and quality engineering space from last 13 years. Today I will be discussing a little bit on Convergent quality engineering, where we are talking about integrating a shift left and shift right testing, basically unifying the shift left and shift right for enhanced software resiliency. Let's get into the next slide. So to talk about today's quality challenges, first thing is obviously you have the development silos where you have all the development and your functional testing and everything happening in one place. And then you have other side is the operation excellence and operation disconnect, right, where production feedback loops separated from the developer life cycles. And let's say you have the something missed in the development. If the bug is not detected in development or functional testing phase, it will be too late for late detection. You are finding it in either production or even in UAT, right? The time to fix the same bug when you find in development is going to be much less compared to the same bug found in either UAT or production. It's going to be very costly to fix it. And obviously, the fourth one is market delays, right? The slower release cycles due to this fragmented quality process, it's going to take longer time to market. And in this fast-paced software development era, right, you want to market your software as soon as you can to the customers or whoever is adopting your software, right? So what we're talking about is having that continuous quality loop, the shift left testing. You have the preventive quality measures during the development, whatever it may be, unit testing. You have the integration testing, different pre-commit hooks, or even some tests running on the CI. Or you have the continuous monitoring where you have real-time quality metrics throughout the deployment, or shift right validations where you have a reactive resiliency testing in production, and you have that feedback integration, right, insights from production, informing the development priorities, right now as of today in this era. What's happening is each of these working as a each one silo, right, where you have four different aspects, right? And what we are talking about, how we can decrease this time between these loops so that you can have better software development and resiliency. So to talk about a little bit of shift left methodologies, right? What we have is obviously developer testing, where you have they are writing the static unit tests, and then maybe a little bit of integration testing, and you have automated CA validations. It may be part of your Git commit hooks, or it's running part of the CI/CD when you merge the PRs. And then you have the augmented testing with a behavior-driven development, maybe the Cucumber tests or WebDriver tests or whatever you have, right? Playwright or different functional tests you have. You can think in the same thing in inverse pyramid, where you have the developer testing should contribute to more than 50%. And then you have the automated CA validations running different integration tests will go into 30%. And then you have functional testing for 15%. At the end, where you have end-to-end testing is for 5%. So when it comes to shift right techniques, right, where you have the advanced observability, right, where you have a granular insights into the production behavior patterns, you have so many different tools like Dynatrace, Splunk, or Grafana. All these tools are available in the market. And you have again the chaos engineering where you have intentional system disruption, right? Every cloud provider have their own tools. AWS has the AWS fault injection simulator, or Google Cloud Chaos Engineering, or Azure Chaos Studio, or even you have standalone tools like Inline or Chaos Mesh or Litmus, right? And then you have the third thing is the canary deployments, where you don't deploy to the 100%. You start with the very small rollout, like the 1 to 2%, or like start with the A/B test or CCM switches, right, where you start to minimal users. And if you find any bugs or fix the bugs, and then do the incremental rollout to the more users. That way, you are introducing the bugs to the smaller customers, smaller set of customers, and then fix it to do the incremental rollout instead of rolling out to 100%, and then the damage will be more. Obviously, last one is the performance monitoring, right? A real-time analysis of the system performance matrix, right? You have a Prometheus with a Grafana or InfluxDB. Even the cloud providers have their own native tools, right? AWS CloudWatch or Google Cloud Monitoring or Azure Monitor, right? So what we are trying to do is like whatever the tools I was mentioned in the shift left or shift right, how we can have a cohesive unifying orchestration where each of these tool work as a one agent, where you have the agentic approach. Each agent is solving one problem. At the same time, how they can interact with each other to have a better communication and the faster development life cycles. Let's talk about a little bit of that. Let's talk about first is the implementation challenge where you have a cultural transformation, right? This is a obviously shifting mindset from testing to quality engineering, right? Where you used to have like where the testing is a separate domain to where you want to come to the point where the quality engineering or quality is owned by each person in the team. From you're talking about from product to program to development to the SREs or DevOps person, whoever it is, everybody have that they have their quality engineering hat on their head. And the second thing is having the tool chain integration, right? Connecting these disparate quality systems across the life cycle, right? If to give you an example, what I'm talking about is if you talk about a unit test, for example, unit testing is a one agent, or your integration testing is one agent, or your functional testing is one agent, or your DevOps checks or mid checks is one agent. And then you have the observability or operation excellence side, right? All the performance or chaos engineering observability tools, what we talked about. Each one think as at one agent, and each one performs one diligent task and a specific targeted task, so it can give you the result. But what you're talking about, having that agent to agent protocol where each of these systems or agents can talk to each other more cohesively in one orchestration, that way anywhere the fault tolerance you have, it will communicate it to the developer more faster, and the fix is done in more faster way to release the rollout or fix to the customer more faster. To accomplish that, obviously, you need to have the skill development. We are talking about building a T-shaped quality professional with a cross-domain expertise. What is a T-shaped quality professional? Basically, T-shaped quality professional is the one who has a depth in one area, but they are a width, mean to say they have the jack of all trades in all other areas. To give you example in quality engineering, right? Somebody might be like their depth may be in like a quality engineering, their expertise in test automation or code review or API testing or CI/CD pipeline building knowledge. Maybe that is their core competence or depth. But what we are talking about with that, if somebody can have the width, right, from operation excellence standpoint or site reliability standpoint or observability standpoint, on the other side, they have all the tools available in the market and what specific task or target problem they're solving. The same thing on the development side, right? What are the tools available? What are the things we can be done for the quality side of things, right? If you talk the same thing here, if you see the core quality competence, right? They have quality risk assessment or test strategy development or defect analysis or quality matrix design, or from operation skills side like observability, tooling or performance analysis or chaos engineering or production monitoring, right? So if you have that kind of a resource available, then you can have this phased adoption model, right? Obviously, anything new you want to implement, even if for a small software team, it's big ship to tier, right? So if you want to move the ship or make a turn, it's going to take a large amount of time. But when you make the turn properly to the right direction, it's going to give you the better results. To talk about the foundation, right? The established core matrix and baseline current quality performance, where we stand today and what we are trying to accomplish. And then obviously the second thing is how the connecting these development and production quality tool chains, right, that I was talking about, different agents and orchestration, how you can have these cohesive systems built. You can do the POCs and see what all the off-shelf tools available or any of these cloud provided tools available, and see how they can fit into your ecosystem, because everybody has different ecosystem, different set of cloud tools they are using. And obviously use a lot of automation in this automation era, right? Implement AI-augmented testing or automation tools to get the better results. And obviously the maturity, right? Achieve self-improving quality ecosystem with the predictive capabilities, right? End of the day, obviously, even if you do the POC and implement, certain things will work out the way you want it to. You will have the positive results and you will have a negative results, and see the whatever the learnings from that negative results, how we can make it as an opportunity to learn more and implement and have a better results. These are some empirical results from some of the published papers from the teams that are implemented these T-shaped professionals with jack of all trades knowledge in all the areas. They are able to accomplish that 78% of defect reduction and 63% of faster detection of the bugs and 42% of incident declines and 3.2% of ROI. And that is a very good results, whatever the investment you are making, if you can get in this fast phase software development era, right? And this is one of the case studies. Obviously, from financial services side, the deployments are like normally release cycles are very bigger. But if you see at this starting point, they used to have 12-week release cycles and 85% manual testing and siloed QA and SRE teams. When it transformed into this agentic approach where they have unified quality metrics, cross-functional quality guides, and production telemetry in test environments, all these things, they are able to achieve the 2 weeks release cycles, 73% automated coverage, and 58% reduction in incident response time. I know compared to a lot of these big tech companies where you have like everyday releases, this might look like very far. But if you think about financial services, any bad move you make, it's going to cost you a lot in customer and even the financial damage. So this is a really good results if you think about financial services business perspective. And obviously the AI augmented quality tools, right? In today you have like for every problem that you are facing in quality engineering, right? You have tools available for self-healing tests, even for the machine learning algorithms automatically repair your broken test scripts without human intervention, right? You can give your Figma changes to your AI agent. It can go and fix your automation tests and get the results. And intelligent test selection, right? The same thing, you can give your product designs and your product or business documents and everything. You can come up with the proper test cases. Excuse me. And obviously the third one I'm talking about is anomaly detection, and fourth one is the code quality prediction. So all these things can be achieved with the AI augmented quality tools available in the market. There is so many different tools like a Test Sigma, Rapid tools. Everybody on top of the game with all these tools. You can definitely explore more. To come to the conclusion, the key takeaways from what I'm talking about here is the integrate quality loops, connect the shift left prevention with the shift right validation for complete coverage. So you have complete pipeline built where each of the agent communicating with each other with more cohesively, and that way your development lifecycle time is less and you have less bugs. And even if you have a bugs, the faster time to fix and market it. And leverage AI capabilities as much as you can. Implement intelligence-driven testing to reduce maintenance burdens, and obviously develop T-shaped teams where you have all the any resource, right? Somebody who has a width and also they have the jack of all trades width and the depth in a certain area of their proficiency. And measure holistically, see where you stand today and where you want to reach and how you can reach your goals. I think that with that I'm done. Thank you very much.